Welcome to section 1.4, Composition of Functions. At the end of this section, we should be able to answer these questions. What is a composite function? What are the various notations for a composite function? How do we evaluate composite functions given graphs and tables instead of equations? How do we determine the domain and range of a composite function if the original functions have limited domains and ranges? What is the distinction between domains and ranges? So let's quickly review what a composite function is and the notation we use to denote a composite function. First of all, I think most of us have seen a composite notation for a composite function written in this manner, f of g of x, where function g here is called the inside function, and that's the function we work with first. And then function f, therefore, would be the outside function. And we take the answer we got from the inside function, or g of x, and we use that to evaluate f. Now, this is the notation we're most familiar with, but there are other ways to indicate that we're dealing with a composite function. This f circle g of x, and then just f circle g without the x. So all three of these notations represent composite functions where g is the inside function and f is the outside function. Now the domain of these composite functions are dependent on what happens as we evaluate a composite function. So we start with the domain of g. We can't use any x values that wouldn't work in our inside function. But that inside function gives us answers that have to be plugged into our outside function f. And those answers have to be within the domain of f. So what we say is the domain of f composite g is the set of all values of x in the domain of g for which g of x is in the domain of f. In other words, anything we can use in g that gives us an answer that we can use in f. That's how we determine the domain of a composite function. Now let's do a quick example of how composite functions work. First, we'll take our two functions. We'll let f of x be 2 to the x, and g of x be the square root of x. And we will try and evaluate these three different composite functions. First, let's find f of g of 3. Well, as we know, we start from the inside, so we need to find g of 3, and that would be the square root of 3. So let's pull out our calculators and find the square root of 3, which we find to be 1.732. So that's approximately 1.732. Once we've found the value for our inside function, we plug it into our outside function, which is f. So we need to find f of 1.732, which would be 2 to the 1.732. So let's go back to our calculator, and we will take 2 raised to the last answer we got. And we see that that's approximately 3.322 if we round. If we check our answer here, $3.322. Now, let's find our second question. Instead of f of g of 3, let's find g of f of 3. In that case, we'll start by finding f of 3. So f of 3 is 2 cubed, or 2 to the third, which is 8. And then we need to find g of f of 3, or g of 8, which would be the square root of 8. Which is also 2 square root of 2, if you do a little algebra. And if we want to find that numeric value, we go back to our calculators and take the square root of 8. And we find 2.828. So this is approximately 2.828. So far, so good. Now let's find f of 3. Now that's interesting because we're using the same function for both the inside and the outside. So we've got sort of a loop here. So first let's find f of 3, which we already have actually. F of 3 was 8 right here. Now so we find f of 8 to be the next step, which would be 2 to the 8th power. If we run the math, I'll let you do that on your calculators and see if you get 256. Here's another example, only now we don't have equations for f and g. We actually have graphs, a graph for g of x and a graph for f of x, and we're going to be asked to find f of g of 30. So while the situation appears to be different, the process is still the same. We work from the inside out. So we start by finding g of 30. When x equals 30, we see that y is approximately equal to 2.8, let's say. That's approximate. Now we take that answer that we got for g of 30, 2.8, and we apply it to the graph for f, where 2.8 will be the x value on the graph of f. From that x value we go up and then over to find that f of 2.8 is approximately 170. Let's look at one more situation. Here we don't have an equation or a graph, but instead we have a table of values for which f and g of x are defined for only certain values of x. Let's try and find f of g of x for the 6 values of x that were given here in this table, which means we need to find f of g of 1, f of g of 2, f of g of 3, f of g of 4, f of g of 5, and f of g of 6. So finding f of g of 1 means that we need to evaluate g of 1. So g of 1 happens to be 5. So we need to find f of 5. And if we follow that logic for f of g of 2, we need to find f of 3, because g of 2 is equal to 3. F of g of 3 is going to be f of 2. F of g of 4 is going to be f of 1. F of g of 5 is going to be f of 7. And f of g of 6 is going to be f of 4, because once again, g of 6 is equal to 4. So now we go back to the table to find these values. When x is equal to 5, f is equal to 0. When x is equal to 3, f is equal to 6. When f is equal to 2, f is equal to 4. When x is equal to 1, f is equal to 3. When x is equal to 7, we don't have a value for f of x when x is equal to 7. There's no value in the table for x is equal to 7. So we're going to have to say that this question, f of g of 5, the answer does not exist, or DNE. And the reason it doesn't exist is because the answer we got when we plugged x into g, so our answer, or g of 5, does not exist in the domain of f of x. We would say that The answer does not exist because g of 5 or 7 does not exist in the domain of f of x. Let's go down and finish off the question. F of g of 6 is f of 4, which is equal to 2. Now, let's use the same process. We're being asked to find g of f of 2 and compare it to f of g of 2. So g of f of 2. We need to find out, working from the inside out, when x is 2, f is equal to 4. So we are trying to find g of 4, which is equal, from the table, to 1. Now, f of g of 2, we already found to be equal to 6. So f of g of 2 is not equal to g of f of 2.